On Earth, we can turn on the TV and see a beautiful rainforest or a mountain or a cool city we may be able to visit at this moment in time. Although we may not be able to visit that city due to work or school constraints right now, we technically do have the ability to go there if we really wanted to. This isn't the case with locations in outer space, however. Most of the things we can see up in the night sky with our eyes or telescope, we cannot visit even if we really wanted to now. You'll find out why in just a second as we explore the speed of light and the vast distances of the cosmos. The speed of light, denoted with a lowercase c, is a finite value that's equal to 299,792,458 meters per second, or 186,282 miles per second, whichever one tickles your fancy most. That speed is so extraordinary, it's really hard to imagine what it's truly like. Let's say your car has a top speed of 120 miles per hour. Light would be over 5.5 million times faster than this. Can you imagine the distance light can cover going that fast? The distance light, that is to say any form of electromagnetic radiation, travels through a vacuum in 1 year is known as a light year. That's equal to any of the following: 0.3066 parsecs, where 3.262 light years is equal to 1 parsec, 63,240 astronomical units, AU, where 1 AU is equal to 1.5 times 10 to the 8th kilometers, or 9.46 million kilometers, or 9.46 times 10 to the 12th kilometers. Okay, but enough of the boring numbers. Let's get back to putting things into perspective for you, since these numbers are so huge. There's a famous galaxy called the Andromeda Galaxy, which is over 2 million light years away. You can see this galaxy in the night sky with the naked eye. Alas, unlike the city you see on your TV screen you may want to visit one day, you won't be able to visit the Andromeda Galaxy just because you can see it. The fastest rockets we have travel around 30,000 miles per hour, or 262,980,000 miles per year. That seems fast, but remember, even if we could reach the speed of light, a value nothing can go faster than, it will still take us 2 million years to reach the Andromeda Galaxy. We need to first hope scientists figure out a way we individually can live 2 million years before we even begin thinking about building super-fast rockets. Who cares about super-fast rockets if we can't live long enough to reach our destination anyways, even when going at the speed of light? Actually, the light that we see coming from the Andromeda Galaxy right now left that galaxy well before our species even evolved on this planet. The time that has passed between when light was originally emitted by a source and when we detected on Earth is known as the look-back time. We are looking back at, or seeing the Andromeda Galaxy as it was 2 million years ago, not as it is now, because light travels at an incredibly fast, but still finite speed. If you're having trouble grasping this concept, not to worry. Think of light as a piece of information, like a message scribbled on a note. Let's say that you live in New York City, and a friend writes a message to you from LA. That message is sent via a mail truck from LA to New York City in 5 days' time. When you receive this information, it's already 5 days old, even though you just received it. It may be new to you, but it is 5 days old to the sender. This is why many of the things we see up in space are what they were like thousands, millions, or billions of years ago. For all we know, some of the objects we see from really far away are no longer in existence, even though we still see them as the light they emitted long ago finally reaches Earth from vast distances away. If aliens have visited us from other galaxies, we should stop caring if they have super-fast ships and start caring about how long they can live. Because even at the speed of light, a finite value denoted with a lowercase c, it will still take them millions of years to reach us from distant places. The distance light, that is to say any form of electromagnetic radiation, travels through a vacuum in 1 year is known as a light year. And that's equal to 63,240 astronomical units, or AU, where 1 AU is equal to 1.5 times 10 to the 8th kilometers. Because light travels at a finite speed, we see very distant objects in space as they once were, not as they currently are. The time that has passed between when light was originally emitted by a source and when we detect it on Earth is known as the look-back time.